this is Andrea Hendricks. The topic of this video is sum and difference formulas. These are formulas that you're not going to need to have memorized, but you should be at a comfort level with working with them. I have the formulas listed here, copied from your textbook. We have a sum and difference formula for sine, sum and difference for cosine, and sum and difference for tangent. And so this is going to provide a way, if you have an angle that you don't know the exact sine or cosine value for, you can rewrite it in terms of two angles that you do know and expand it to get an exact value for that trig function. So just kind of notice some patterns here. With the sine formulas, notice sine and cosine are together. The middle sign is the same as what we started with in sine, and then cosine and sine. For cosine, the cosines are grouped together, the opposite sign and the sines. For tangent, you have the same sign in the numerator and then a different sign in the denominator. I will tell you the one that I could kind of remember from my head is the cosine, and the way I think of it is, if you think of cosine, C-O-S, you have your cosines together, you have opposite sign, and then you have your sines together. So cosine U, cosine V, opposite sign, and then sine U, sine V. And that, if I remember that one, I can always get the signs from there. You don't have to memorize them, but just a little tidbit. Okay, let's look at how we can practice applying these. So from problems in your textbook 15 through 22, what you're to do is try to find the exact value of these trig functions. Now you can obviously put into your calculator and get an approximation quite easily, but let's say if we wanted to work with number 16 and find the sine of 15 degrees. What I want to do is rewrite sine of 15 as the sum or difference formula. That is, are there two angles on the unit circle that I know that either adding or subtracting gives me 15? Well, would you agree that 15 is the same thing as 45 minus 30? And I know all the trig values for 45 degrees. I know all the trig values for 30 degrees. So I could use this formula now to expand it to get the sine of 15 degrees. So the sine of 45 minus 30, if we use our formula, would be the sine of 45 degrees times the cosine of 30 degrees minus the cosine of 45 degrees times the sine of 30 degrees. Okay? And now, what is the sine of 45 degrees? Well, yeah, it's the square root of 2 over 2 times the cosine of 30 degrees would be what? The square root of 3 over 2. Cosine of 45 degrees is square root of 2 over 2. And the sine of 30 is 1/2. So this gives us the square root of 6 over 4 minus the square root of 2 over 4. Combining those gives us the square root of 6 minus the square root of 2 over 4. Because we have the same denominator, we can add the numerators. Now understand, I can't simplify the square root of 6 minus the square root of 2 any further, because for radicals I can only add like radicals, and these are not like. So that would be an exact value for the sine of 15 degrees. Now, what if I wanted to look at number 20 just to get you started? Oh, well, let me back up. You could do cosine of 15 degrees in the same way. Just use cosine of 45 minus 30 and use that appropriate formula, and tangent of 15 in the same way. So what if I wanted to do, let's do cosine of 5 pi over 12. Now, with 12s, generally speaking, you can think of 3's and 4's added together, because the common denominator between 3's and 4's are 12, or 2's and 6's added together as well. So I try to think about, well, how could I get 5 pi over 12? I could do that as, what, 3 pi over 12 plus 2 pi over 12 adds to 5 pi over 12. Well, 3 pi over 12 is really pi over 4, and 2 pi over 12 is pi over 6. So I can rewrite cosine of 5 pi over 12 as really cosine of pi over 4 plus pi over 6. Now I'm going to apply the sum formula for cosine. So the cosine, remember, I have cosine of pi over 4 times cosine of pi over 6. Then we have to do the opposite sign, and then do the signs together. Sine of pi over 4 times sine of pi over 6. So what is cosine of pi over 4? Yeah, that's a known value, the square root of 2 over 2. What about the cosine of pi over 6? Right, pi over 6 is really 30 degrees. Cosine of pi over 6 would be square root of 3 over 2. Minus, what about the sine of pi over 4 is the square root of 2 over 2. And the sine of pi over 6 is 1/2. So we get this to be what? Square root of 6 over 4 minus the square root of 2 over 2, which is, I'm sorry, square root of 2 over 4. So we get the same result. It's the square root of 6 minus the square root of 2 over 4. Now let's look at number 22. I'm not going to work this one out, but I just want to get you started in this problem. I've got to think about rewriting negative 13 pi over 2 as a sum or difference. Generally, when you have a negative sign there, you need to have one positive and one negative, right? We could write this as, would you agree, 13 pi over 12 is the same thing as 3 pi over 12 minus 16 pi over 12. Well, 3 pi over 12 is the same thing as pi over 4 minus, if I reduce 16 pi over 12, I get that to be 4 pi over 3. And those are all angles on the unit circle that I could then apply the sum or difference formulas to get the result that I need for the exact trig values for this angle. Now, the next set of problems, you're just working in reverse. You're trying to figure out which pattern did these combinations follow, and then extract those out and put it in the appropriate formula. So like cosine of 60 times cosine of 20 minus sine 60 sine 20. Well, notice we have the cosines together, the sines together, so that's one of our cosine formulas. In fact, that's going to be the cosine of 60 plus 20, right, because the opposite sign is used in the expansion, so we need a plus inside. So that's equivalent to the way you would write cosine of 80 degrees. Sine of 110, cosine 80 plus cosine 110 sine of 80, that's an expansion of the sine. And the sum formula, because the same sign is used here, so that's 110 plus 80. So that's the way that you would expand the sine of 190 degrees, okay? Then the next grouping of problems is just to verify the identity. Well, here you're just going to apply those formulas that we have known and use the sum or difference to expand it and simplify to see that you get the right hand side. So like number 64, for instance, I would need to expand the sine of 3 pi minus x and see if I come up with cosine x, or sine x. Well, we start by expanding this using the difference formula for sine. So this is going to be equal to the sine of 3 pi times cosine x, right? And then we have the same sign minus the cosine of 3 pi times sine x. Well, what is the sine of 3 pi? If you use your unit circle, 1 pi, 2 pi, 3 pi is wrapped around 1.5 times. That point of the unit circle is -1, it's 0. So the sine of 3 pi is 0. So it's 0 times cosine x. What about cosine of 3 pi? Well, it is -1, so we have minus a -1 times sine x. 0 times cosine x is 0, minus a -1 would be plus 1 times sine x. So we've proven what we needed to show. Working with number 66, we have to use the expansion for the difference of a tangent. Tangent of pi over 4 minus theta would become tangent of pi over 4 minus tangent of theta divided by what? 1 minus, I'm sorry, that's opposite sign there, 1 plus tangent of pi over 4 times tangent of theta. Well, what is tangent of pi over 4? Right, that's where sine and cosine are the same, so when we divide it we get 1. So that's 1 minus tangent of theta divided by 1 minus 1 times tangent of theta. I'm sorry, I said minus again a bit, plus tangent of theta. And we've shown exactly what we needed to. Okay? I'll do one more. Let's do number 68. If you want to start with that, cosine x plus cosine y plus cosine of x minus y is show that we get 2 cosine x cosine y. We could do that. So cosine x plus y is cosine x cosine y minus sine x sine y. And then we expand the cosine of x minus y to get cosine x cosine y plus sine x sine y. Well, fortunately, the sine x sine y cancels out, and we're just left with cosine x cosine y plus cosine x cosine y, like terms which add to 2 cosine x cosine y, and that's it. So if you have any questions on these, please don't hesitate to contact me. Thanks.